Hi, AP Physics. Today we're going to be learning about torque. And the first thing that we should know is the definition for torque, and that is the cause of change in rotational motion. Now, this should remind us of the definition for force, or it should sound very similar to force because force is the cause of change in linear motion, right? If I am going to push something, it's going to be the mass times the acceleration. And a force is the thing that causes something to accelerate. Now, if I want to change something's rotational motion, it's got to be a little bit more specific than force, right? Because a force causes something to accelerate linearly. If I apply a force to any part of the object, it's going to accelerate linearly. But to cause something to begin to rotate, it requires something a little bit more specific. So when we try to rotate a door handle, so here's a door handle here. Okay. If I want it to begin to rotate downward, right, or in the clockwise direction, I can't just apply my force anywhere. And if I want to be the most efficient with my rotating the door handle, I'm going to want to place my force at the very end of the door handle. Okay. And I want it to be perpendicular to the radius of my door handle. So torque, which we define by the symbol tau in Greek, is equal to the cross product of the radius times the force. This is similar to the dot product, where you multiply the components that are in the same direction together. But here we are going to be taking the perpendicular components and multiplying them together. So notice that the radius and the force are completely perpendicular, so I am only going to be taking those like components. The components that are dislike, right? Radius is horizontal, force is vertical, and I'm going to multiply them together. Now, if my force was at an angle, I would take the radius times the force, and then I would take sine of theta here. So let's change the angle of my force. Let's see how that would actually work here. So I have placed the theta in that close corner, and I want the perpendicular component, so I want the force in the y direction here. So as you can see, right, it's going to be the sine of theta that we're going to be using to solve for our torque. Now, the nice part about this is there's lots of rotating things all around us, right? A book, it opens and rotates. A door rotates. Your refrigerator, your cabinets, so many different parts of your everyday life have rotating objects. And so you can see for yourself that placing the force at the very center, no matter where it aims, it will not cause your door handle to rotate or the door itself to rotate. If I have a radius here and I apply my force in the anti-parallel direction, right? If I push into the door handle or I have it in the parallel direction here, won't cause rotation either. So this is really important for us to think about. Now, let us be careful. Torque is not equal to force. These two things aren't the same, right? A torque is something that is a little bit more specific. It requires you to apply that force at some radius. So this is a very simple introduction to torque. Check out the designing a bridge or making a bridge video to see how rotational statics work with torque and force.